What's up, guys? In this video, we'll talk about controllers, events, and models. We're going to add events to our controls, then catch those events in our controllers. Then we'll move on to models and update our orders table. By the way, if you are new to this channel, make sure to like and subscribe. Also, make sure you stick around to the end because I'll share with you a JSON tool that you can use in your project, which is very useful for making model data and for testing. Without further ado, let's get started. As a review in our previous video, we added the table control to our homepage. We also added the header toolbar, which contains the search field and some buttons for sorting and grouping. We also added table columns and updated our table row items using column list item. We'll now move on to the MVC aspect of SAPUI5 or the Model View Controller design pattern. The view, which is our home view.xml, is composed of controls and aggregations. It is responsible for defining and rendering the UI. The view notifies the controller for any event or interaction from the user. The controller is responsible for controlling the flow of the application execution, and it can notify the model to get or set the data. The model can update the view through data binding, or it can notify the controller as well for any data changes. The controller can also modify the view depending on the business logic, and this completes the MVC design pattern for SAPUI5. One may ask, why use model if we can modify the view via controllers? First, the code is more organized, manageable, and debuggable, and by moving the data to the model, it reduces the number of data loss related to application lifecycle. The code also becomes very modular in MVC, and since the model doesn't need to know the specific of the business logic, it also reduces hard references of control IDs since we are working with data binding. Alright, now that we are familiar with MVC, let's get coding. We'll start by adding an event to our search field. Let's type search. I'm gonna set that to a function called onSearch. Alright, so search field now contains a search event, and that search event is calling a method or a function named onSearch. So let's save that and run our application. So let's try to search in our control, and as you can see, it doesn't do anything because we haven't declared the function itself. Now to define that method, we'll go into our controller. Inside the controller body, after the last curly brace of onInit function, we'll add a new function which is called onSearch. For now, we'll just show an alert message to make sure it works. Save that and run your application. So let's try to search. Press enter. Now the event is triggered from our controller. Let's also add events to our sort and group button. Don't forget to attach the events in your home view.xml. So I'm using the press event for the button on sort, press event as well for on group. Save your application and run. Let's test our sort button and our group button. Alright, it works. There are also SAPUI5 standard control functions, or called Lifecycle Hooks. Lifecycle hooks are a bunch of functions that controller goes through from creation to destruction. onInit, on before rendering, on after rendering, and we also have on exit. Each function can be overwritten to apply your logic to the application. OnInit is for one-time initialization, while the counterpart of OnInit is onExit, which is when the view is destroyed and gone forever. On before rendering and on after rendering are related to the visible parts to the user. On before rendering is always called every time the view is rendered, before the renderer function is called and the HTML is placed on the DOM tree, while after rendering is called every time the view has rendered and after the HTML is attached to the DOM tree. On after rendering is useful when you want to do some post-rendering manipulation to the UI. Alright, let's try these functions on actual code. So what I've done here is to add an alert message to each lifecycle hook function. I'll also add a destroy function to our sort button just to trigger the onExit event. Let's get the view first. After getting the view, let's destroy the current view. So when we press the onSort button, the current view will be destroyed and the onExit function will be triggered. So the first function triggered is the onInit, and then on before rendering was triggered before the view is rendered, and then on after rendering is after the HTML is attached to the DOM tree. Let's try to trigger the onExit. So press the sort button. The sort alert message is triggered and was followed by the onExit event. Most of the time, you'll be setting your controller variables and routes inside the onInit function, and then call the models and load data on your on before rendering, since it's triggered every single time the view is rendered. While on after rendering can be used to manipulate, for example, the scroll of the view after it was rendered, while onExit is used to clean up some controls and variables before the view is destroyed. Alright, now that we are familiar with lifecycle hooks, let's proceed to models. I'll just comment out some of these alerts since we don't need them. A model in the model view controller concept holds the data and provides methods to retrieve the data from the database and set the data or update the data as well. There are two categorization of models, the client side and the server side. Client side models are models that are only stored in the user's device or the browser. These are the JSON, XML, and the resource model, while the server side models are stored remotely like your OData version 2 and OData version 4. So right now, our current view doesn't use any model to store the data. Most of the values are hard-coded in our XML file or declared in the view itself. Alright, let's try to import the JSON model to our controller. Let's import the JSON model and then declare that dependency as a parameter. Inside our onInit function, let's try to list down the steps that we need to do to create and assign the model to our current view. First, we need to create a data object, and then we need to create a JSON model instance, and after that, we need to assign the JSON model to the current view. So let's declare a variable OData that will contain our data model. Let's add a property called title and set its value to my orders. Next is to declare a JSON model. var omodel new JSON model. Pass the created data object to the JSON model parameter. This will create a JSON model instance that we will assign to our current view. So to do that, let's first get the current view by this.getView, then set its model to the JSON model. So now the view will point to our JSON model and reference all the data that we've assigned to our data object. Let's save that and run our application. As you can see, there are no visible changes to the view. Next step is to use data binding so that the view knows which part of the model to use. Let's bind the title of our table to the title property that we declared a while ago. So go to your XML view, and then inside the title, change the text, and using data binding, point it to the title property. So what we are doing here is telling the title control that the text property is using a reference and the path to that data is /title. We added a slash indicating that it's the root node of the data object, and then title as the property that we want to bind. Data binding follows a specific syntax with curly braces, and inside the curly brace is the path to your model data. Okay, so let's save and rerun our application. Now our table title displays the model data My Orders. What we actually did so far is called property binding. We initialize a property and it automatically updates based on the data from the model. The next concept that we need to understand are binding modes. Binding modes defines how the data is reflected to the model. First is two-way binding. Any changes in the model is reflected to the view, and any change to the view is also reflected back to the model. Next is one-way binding. Any changes to the model is reflected to the view, but any changes to the view is not reflected back to the model. And finally, we have one-time binding. Unlike the two previous binding, the model data is read only once and reflected to the view. Any changes to the model is ignored. Let's see this binding mode in our code. By default, JSON model uses two-way binding, which means the title text property will be updated for any change from the model or view. Let's also bind the search value to the data title. In search field, let's type value and data bind this value to title as well. Alright, let's try to edit the search value. Any changes from the UI is also reflected back to the model. That's why our table title was also updated. Let's try to change the binding mode of our JSON model to one-way binding. Again, let's change the search value. Now, as you can see, the table title is not updated, since any change from the view is not reflected back to the model. This is one-way binding. Next is one-time binding. This type of binding is usually for non-changing properties like our translation and resource model. So as you can see, our I18N is binded to the title property. Since the translation file is constant and doesn't change much during the application lifecycle, it is only read once and not to be updated. Our next step is to add a new property to our data object and name that property sales order set, which is similar to our ES5 entity collection. So what we've done here is to create a list of orders that will be used in our table. So we have sales order 1, and then we have another sales order, and then our last table entry. And as you can see, each row represents a single order with different properties for sales order ID, customer name, lifecycle status description, lifecycle status, gross amount, and currency code. So let's try to bind this data model to our table. In our table, instead of using a property, we'll now use an aggregation items, which is the aggregation that we use to create the rows, and then assign that items aggregation to our sales order set. So we added a data binding for the items aggregation. So we are telling the table that we have items aggregation, and that items aggregation will be generated or will reference the data from the sales order set. Then down below, we need to create a template that our items or aggregation binding will use for generating the rows. Items here is like your for loop, and the items aggregation below is like your for loop body. We can now delete the remaining column list item, and I will give the source code on the description box below. As you can see, we bind the properties of the template to the properties of our sales order set. For example, the object identifier title property now points to the sales order ID. Also take note that we don't have a slash in here since we are inside the for loop of the aggregation. We can now just relatively access the property. So save your XML and run the application. Now we have updated our orders table, and it contains dynamic data from our aggregation binding. Now it's time to share with you a very helpful tool when dealing with JSON. Just a disclaimer, I'm not sponsored by this website. I just find it really helpful when editing complex data. The site is called JSONEditorOnline.org. I use this website to create JSON data and then export the generated JSON data to my project or my controller. So you can either edit your JSON here. For example, if you have a messy JSON code, you can actually format that JSON code and it will automatically beautified. So you can minify and then you can format as well. And then you can copy that content to your right panel and it will be automatically converted to a tree view, which is easier to edit than the text or the plain text. You don't have to worry about the delimiters and missing double quotes. And then you can copy that tree view. Example, I edit the sales order ID and then copy it back. So you can just simply copy the contents here and then paste it in your project. So we're done updating our table in our homepage. We also tackled events and what are the lifecycle hooks for our controller. In the next lesson, we'll connect our remote backend service ES5 and update our current table and use that remote OData service. And we'll also add filtering, sorting, and grouping to our user interface in the succeeding video. So please don't forget to subscribe if you haven't and leave a like if you like this video, and I will see you in the next one.